Hello and welcome back. The last video we spoke about the general architecture of the 8086 interrupt system. Today I'm going to be talking about a specific peripheral device that you can connect to the 8086 for managing interrupts, fairly complex interrupt systems that the 8086 on its own may not be able to do. This is called the 8259 Programmable Interrupt Controller. Right, so it controls interrupts and the 8259 itself can be programmed. Remember, there are only two interrupt lines for the 8086 and you cannot make a complex system with just two interrupt lines. You need something more. Right? The 8259 PIC gives you that option. It can support 8 hardware interrupting devices on one chip, and whenever the interrupting devices delivers a signal to the 8259, it will interrupt the processor and deliver the correct interrupt service routine vector address to the processor. Let's look at the architecture of the 8259. Right? This part of the 8259 interfaces with the processor. These are the signals that are required to interface to the 8086. Data bus, the read-write signals, and the control signals, the interrupt and interrupt acknowledge lines. Obviously, there is a chip select that you need to have to select the 8259 based on the address that you have mapped it to. This part is the heart of the 8259. It controls the interrupting systems from the external world. Right? So the 8 external interrupt lines come into this block. So inside the 8259 you can actually store the actual interrupt requests that come from external interrupting devices. This particular block, which is called the in-service register (ISR), tells the 8259 what are the interrupts that are being currently serviced by the processor. So it's kind of a buffer between the interrupt request register and the interrupt and the 8086. So it kind of maps the two together. The middle block, this logic block, determines a prioritization. Right. So this is therefore a prioritized interrupt system. And you can say a keyboard has got a higher priority than an optical disc, or the mouse has got a higher priority than a keyboard, etc., etc. Those are things that you can program using the 8259. The last piece of this is what's called the interrupt mask register. So this register allows you to define specific interrupt inputs that you can mask. So of the 8 interrupting lines, you can say I'm not interested in interrupt number 4 and mask it from ever being recognized by the processor. The last piece allows even more complex systems to be built, and that's called the cascading lines, CAS 0, 1 and 2. And the cascade lines allow you to cascade multiple 8259s, permitting up to 64 interrupting devices to be connected to one 8086. And these are useful when your system is that complex. Let's look at how this cascading works. It's called the master slave configuration. I just used two 8259s. Remember, you can have up to 8. So what happens is, first of all, you connect. So let's assume one is the slave and the other is the master. You connect the output interrupt pin from the slave to one of the input pins of the master. And if you had multiple slaves, you would keep connecting the outputs of all those slaves to the different interrupting input lines of the 8259 master. That's why you can have 8 slaves and 1 master. How does the 8259 know whether it is a slave or a master? If the SP/EN bar pin is pulled to plus 5 volts, it is the master. If it is pulled to ground, it is the slave. Data bus is common between both of them, and of course you must connect all the cascade pins together. And all the 8259s in the system are architected this way. The master interrupt output pin goes to the processor. So the processor really sees only one interrupt line. If it sees only one interrupt line, how does it know which of the 64 possible devices are actually interrupting? And what happens here is, as soon as one of the slave 8259s receives an interrupt, it informs the master. The master interrupts the processor, and as soon as the processor is ready to read the interrupt service routine address, the master 8259 informs the slave 8259 to put the ISR address onto the data bus. So the ISR comes from the slave devices but under the control of the master 8259. the processor reads this information and executes the appropriate interrupt service routine. How do you do all of this, right? So I said this is a programmable interrupt controller. What are the kinds of programmings that you can do? There are two things that you must do before you can start using the 8259. I'm assuming the hardware part is perfect. Now you have to program the 8259. One is initializing it, the second is called programming it. There are 4 initialization control words, ICW 1, 2, 3 and 4, and each of those 4 words have a different purpose, and actually different bits of each of those words have a different purpose. In this example, ICW 1 is depicted. The lowest bit of ICW 1 tells you whether the instruction command word, control word 4 is required or not. It tells you whether it is at a single 8259 or there is a master slave configuration that is cascaded. It tells you whether the call address is 4 address bytes long or 8 bytes. So in the case of 8086 it is always 4, right? So the 8085 has got a 8 byte sequence. It tells you whether the interrupt is level triggered or edge triggered, and what is the vector address. The top A5, A6, A7 of the vector address is stored in this particular control word. ICW2 is the higher byte of the interrupt service routine address. So that means so it is the 8-bit vector for the 8086 that gets stored in the ICW2. ICW3, here the mode, the programming that you have to do depends on whether it is a master or the slave. In the case of the master, it just tells you that the slave is present on a particular interrupt line if it is 1, and if it is 0 it tells you that there is no slave present on that. What is the advantage? The advantage is you could connect a keyboard to interrupt line 2 and you could connect a slave to interrupt line 3. And if it is a keyboard, the master itself will deliver the interrupt service routine vector address. If it is a slave, the slave 8259 will then be asked to deliver that. So this particular control word helps the 8259 know which of the interrupting inputs is connected to a slave 8259 or to a direct interrupting device. The last control word is called ICW4, and this is gives you a series of helps you program the 8259 to provide a series of services, whether it is auto end of interrupt or the normal, whether the 8259 is connected to 8086 or 8085, whether it is a master or a slave, and whether it is in what's called a special fully nested mode or not. So it could be a special fully nested mode or it could be a fully nested mode. All those kinds of information gets programmed using ICW4. Once you have initialized the 8259, you can then reprogram it over and over again. But every time you reset the system, you have to initialize the 8259, ICW 1, 2, 3 and 4 first. Then you can start programming it using what's called the OCW, operational command word. There are OCW1 really talks about the masking. So it allows you to mask individual interrupt bits. And you can do this dynamically anywhere during the program. OCW2 determines the behavior of the 8259 in terms of rotation of priority, end of interrupt, so on and so forth. OCW3 is allowing you to enter what's called the special mask mode. I'm fairly textbookish on that. If you look at any textbook on the 8259, you will begin to understand what a special mask mode is. So these are really what are called operational command words. The operational command words can be reprogrammed anytime in your program, whereas the initialization, the ICW, has to happen upfront at the beginning of your program. This, in essence, is the 8259, and kind of along with the understanding of our earlier video, I hope you get a feel for how interrupts are managed in the 8086 world. In our next video, we are going to talk about how to interface memory devices to the 8086. Till then, happy reading. Thank you very much.